Okay, so we're going to move on to lightning talks now. And our first lightning talk of the day is going to be Andree Toonk from BCNET. And he's going to be talking about the open source NMS.
So, good morning, everyone. My name is Andree Toonk. I work for the University of British Columbia here in Vancouver, and our team is responsible for the network management, network engineering, network design of BCNET. And for those who don't know, BCNET is the regional provincial research network here in British Columbia. And we connect basically all the universities, research institutions, students to the internet, to the advanced research networks such as Internet 2 and Canary. In total, our network has about 100,000 users, and we run the network basically all by ourselves, which means from layer 1 DWDM networks, province-wide, as well as metro rings, routers, switches, everything. Our team, though, is quite small. We only have about 4.5 full-time network engineers. So to manage our network, we rely heavily on network tools. So the tools that we are using is a homegrown suite of software to basically capture all information about the network. We've developed this piece of software over the course of about the last 3.5 years. And the main reason why I'm doing this presentation is because we're planning to open source it. We've talked with some of the other regional research networks in Canada, as well as in other parts of the world, and they seem to be quite interested in it. So we rewrote parts of it, and we're working on the last legal details to get it open source. So this presentation is basically to introduce it to the larger community, and hopefully you guys are interested and want to try it out and maybe help us develop it further. So basically it's all it relies heavily on PHP, MySQL, and Apache, and some of the other well-known tools such as RD tool, MySQL. You can use Nagios plugins you can use any of your existing Nagios plugins to do your monitoring. If you have optical equipment, you can use TL1 Toolkit, which is a Perl library I co-wrote with someone else to monitor optical devices. So basically it's all object-oriented API in PHP, but there's also Perl libraries that provide much of the same functionality in Perl. And it also has a plugin framework that allows you to easily extend the software. So what I'm going to do in the remainder of the presentation is just quickly go over most of the functionality, or some of it, because there's quite a few in it. This is what you see when you log in. This is the dashboard. You can see all the submenus on the top bar. There's a search bar. You can basically search for a lot of things. You can fill in interfaces, customer names, IP addresses, AS numbers, and then it will show you all the information it has about that. You see also a number of dashboard widgets. You can easily create your own widget. It really takes about 5 minutes if you have moderate PHP skills. You can move those around, you can add them, delete them, things like that. Widgets that come out of the box are a IP calculator. There's some audit trail. You can see who changed what, added what, things like that. Some statistics about what's in the database, how many devices, customer, recent event changes. And of course, there's a BGPmon widget as well. So some of the features. Devices. So when you start building out a network, one of the main things, of course, is devices. So we document all our devices in there. You can add devices, device types, you give them names, all that kind of standard stuff. You can then also enable it for SNMP polling, and it will start to detect all the interfaces, IP addresses, all that kind of stuff. It will start to automatically do statistics collections. You can also do password management in there, so you can add passwords for a device or any other private type of information. And that's AES encrypted in the database. So there's some security in there as well. It also does automatic threshold warnings, so if you go over a high water mark of 90% or there's errors on interfaces, it will automatically send you an email address or an email, so you don't have to do much for that. When you click on a device, you see multiple tabs. I just selected the middle tab here, which shows you all the interfaces. all the information, that, a lot of information. There's mouse over so that you can see the statistics. You can then click on that, and then it's very similar as in Cacti, and you can zoom in and things like that as well. Also, when you add a new interface, a new logical interface, that's all automatically detected, change interface description, all that kind of stuff. Okay, other things you need to do is location management. So we use it to store details about all our location, all our POP sites. Locations have different rooms, so you can have different room types. You can add contact information, such as security or emergency contact. Which brings us to contact management. Basically, we use it to store most of the contact information for either clients, vendors, suppliers, peers, anything. So you can create new contacts. The contacts is of a certain type, and that's all flexible to configure. Once you have a contact, let's say one of your peering partners, Google, whatever, and then underneath there you can actually create person objects, and then you can add and delete persons. You can reuse them all over the place as well. One of the other things we use it for is IP address management, IPv4 as well as IPv6. I think it's pretty unique because there's not too many open source IPv6 address managers out there. And we also use it for VLAN management. I hope you can see this. This is a screenshot of the IP manager, in this case IPv6. It has a lot of JavaScript, Ajax in it to make it look nice and interactive. You can collapse this. Has different colors for if it's assigned or reserved or some things like that. If you hover over it, you see the details on the bottom of the screen. If you click on it, you get a modal window, and you can assign it to a location, to a contact, things like that. Once you have devices, locations, contacts, all that kind of thing, you can actually start configuring network services, and that's where it all comes together. So if you think about it, a network service, in our case, for example, could be a BGP peering with a customer, or with a VLAN throughout the network, or a BGP peering with Microsoft, for example. Well, that's a typical service. You can create different service types, and that's where you glue it all together. So you say this service, this BGP service is configured on device 1 in Vancouver. It's for customer or peer at Microsoft. It's on this device. It's on this interface. These are the BGP this is the BGP information. These are the prefixes I'm sending. I'm expecting IP addresses, all that kind of stuff. The nice thing is it's also doing per service statistics collection. So if you ever move a client around to another device or whatever, you won't lose any of the historical data because it's using the service ID as the key. We've seen that in the past a lot. So that's nice. You can do per service monitoring. We have a customer portal where it feeds into. Because you associated each service to a customer only sees its own services. You can generate reports, all that kind of stuff. One of the things we also use it for is event management or monitoring and reporting. And in this case, reporting is in bold because the main thing we wanted to use it for is reporting. We use Intermapper mainly for monitoring, but it doesn't have a good features for reporting. So basically, it's heavily inspired on the Nagios framework, which means that you can actually use existing Nagios plugins, including performance data. And again, we use it for reporting mainly. So at the end of the month, we can report on network services. For example, transit availability in Vancouver. We buy transit from 3 different providers. We monitor all 3 of those. And then at the end of the month, we group them together as one service. And then there's some logic that allows you to say, okay, how do you want to monitor or report on these services together? So you can say, okay, if one was down, then the whole service was down, or if, as long as one's up, the whole service is considered as up, which is what we want in this case, because if one provider is still up, the whole service is still up. Or you can just take the average or whatever. There's a lot of different things you can do with reporting there, and it's quite nice. Again, there's a number of plugins and dashboards widgets available. Very famous is the PHP traffic weather map. We use it for traffic accounting, TL1 plugins, change manager. There's a few of those available. I think this is almost the last slide. So this is what you see for checks or event management. So on the left, you see the check details. You create a check template where you say which Nagios plugin you want to use. And then again, it starts really reusing much of the information. You say this is the device. It already knows the SNMP information or some of the other stuff. On the right-hand side, you see the recent events, and at the bottom, you see performance data. Again, this was a really quick overview of the functionalities. There's way more in there, but I can't show you all that. This is the URL where you can find more information. There's more screenshots, videos, and other information. It's currently being evaluated by a number of networks, and we hope that some of you might be interested as well and want to give it a try and hopefully work with us to make it an even better solution. So if you're interested, please let us know. Thank you.
Thank you, Andree. Any quick questions? No, very interesting. Thank you.
Okay, thank you.
Okay, the next lightning talk that we have is going to be Jim Martin from ISC. Jim, he's going to talk about bind 9 and bind 10 and using bind 10 in production.
There we go. So hi, I'm Jim Martin. I'm from ISC, and I want to tell you a little bit about some experiments we've been doing with bind 10, trying to get some reality into it. So for any of you who aren't familiar with it, bind 10 has been sort of a long-term planned replacement for bind 9. It's been largely in the lab for the first 3 years of its life, and we're trying to actually give it a little bit of reality, a dose of reality, to see if it actually is going to work the way it's supposed to. The thought was what we'll do is we'll start throwing AS112 data at it, because if we can, it's a decent amount of real variable day-to-day traffic without it being something that we would actually knock down services if we were to withdraw it. So it seemed like a relatively low risk. We found that it wasn't quite as low risk as we had hoped, but I'll walk you through that. The other key thing about this, though, is that the authoritative portion of bind 10 is very close to user test, and so this is sort of the first steps. So as we started, we got handed off from the software engineering team a bundle of code that they said, oh, sure, just go install it yourself, it'll all work great. Yeah, it's very, very raw still. Between the dependencies and the documentation, there were a lot of things that we were able to go back and forth and try to have the operational aspect really influence things. But finally digged it up, put the normal, ISC's been running a 112 server for a while, so we just flipped the traffic pointing at the bind 10 server, and it died. When we looked at it a little bit, it was entirely a performance thing. The box just could not handle the load that it was given. We saw that we were seeing about 50,000 queries a second. The old bind 9 on a old piece of hardware was doing just fine. The bind 10 on a relatively new piece of hardware couldn't handle it. And we went back and we had a bit of a chat with the software engineering guys, and they said, oh yeah, performance. Yeah, we should really look at that. And so once we did that, we tried to see if there was anything we could do. Nah, not really. So we basically bailed out, flipped back to the bind 9 server, and said, yeah, you guys go off and figure out what you can do to make this actually work. That was 3-4 months ago. Then a month or two ago, we tried it one more time. The good news is that with the gentle nudge of having utterly and completely failed, they went back and did some performance improvements and found that they were able to, without changing the architecture at all, without messing with any of the work that they had been doing, but rather just going through and doing the obvious optimizations, they were able to get it up to the point where it's at the same level as bind 9. There's still work to be done, and they're planning on continuing to do work. But the bind 9 level performance allowed us to put it back into production. So we were going to put it into production, but the last experience caused us to be a little uncomfortable with it. And so we set it up with a bind 9, the existing bind 9 server as well as the new bind 10 server, ECMP'd between the two, figured out that's a little bit of lesser load, give it a better chance. It did just fine. And we then dropped the bind 9 server out, seemed to be doing just fine. We did look, and though that the traffic load had gone from on the order of on the order of 50,000 queries a second to about 15,000 queries a second. So where that really came from was somebody out here, probably stood up another AS112 server somewhere around PAX and sucked off a lot of the traffic that we had been getting. So we're able to establish that it is able to handle a reasonable load, but not quite the load that we originally had. But then it went wrong. We started getting abuse reports coming in and couldn't quite figure out what was going on. Then ended up doing a couple of packet dumps, took a look and realized that while the bind 10 server was getting the queries, responding appropriately, and sending those out, when they were sending them out, it was coming in on the 112 Anycast address and going back out on the interface address. It hadn't really occurred to the bind 10 guys that you might need to preserve that. So the perception was, A, first of all, we were managing to do a disservice to the internet because people were not getting answers to their queries, and B, that we were triggering everybody's IDSs because they saw these as unrequested packets coming from the outside world. So the good news is we were able to work and come up with a quick hack to get that fixed, but there are some architectural changes that they're going to need to go back and really take a look at. The end result, though, is that we have a running production server at this point. It is working. There are no current open issues with the configuration. It's seeing day-to-day traffic, and the engineering folks are using that to use as a basis for building future work. And ultimately, though, this is meant as a first step towards user testing. And so really the main reason me mentioning this is A, admitting that yes, we've got our challenges, but also we're making some real progress to getting this out there. And also as a nudge to you guys, saying that later this fall, we're going to be doing public tests with this, where we're going to be asking for folks to be looking at this for authoritative servers, and we'd really like some feedback. If you want to play even before then, there is the bind 10 list there on the slide. But the upshot of all of this is that, in fact, bind 10 is out there, it is in production, and we're looking forward to having you guys help us out do some testing. Any questions? All right, thanks much.
Thank you, Jim. And then next up is going to be Tom Daly from Dyn, and he's going to talk about weirds.
Good morning, everyone. So I'm Tom Daly. I'm with Dyn. I will say right up front that I don't get to choose these names. But weirds is something that looks and feels like a WHOIS 2.0. I've been collaborating with two colleagues from Dyn, Alex Sergeyev and Andrew Sullivan, on this work, and we wanted to introduce the Nanog community to what the IETF is doing with weirds, but also what Dyn is doing with weirds. So I hired an intern this summer to come look at weirds with us, and he sent me this email, and it was, why use modern protocols? And that was directly going back to the fact that WHOIS is just really, really old in the first place. It was defined in RC 812. That was defined in 1982. And it was primarily designed to contain contact information about networks. It used US ASCII text. It didn't have a defined data format of any sort. It has no support for internationalization, and it was essentially designed as a text-based protocol with the human consumer in mind, not computer systems as a consumer. The WHOIS protocol was then rolled forward in 1990 into the basis of domain name registration contact information, and that's just something that tends to be pretty painful for us all today. You know, who's written a WHOIS parser in the room, right? Like, I should see a lot of hands go up. And I think at Dyn it's something like WHOIS is 37 and our intern program is like -6 or something like that. So it's just not very fun at all. So the IETF has a working group that's working on something called WHOIS, and WHOIS really drafts upon a lot of the work that's already going on at the RIR level, particularly in ARIN and in the RIPE regions, with bringing modern protocol capabilities to the WHOIS. So essentially forklift upgrading this raw text-based socket protocol to things that use, HTTP, REST, JSON, XML, have things like authentication in it, class of service. And ultimately, a lot of this work has been motivated by ICANN's Security and Stability Advisory Committee, their report SAC 051, as well as the output of the WHOIS policy review team. So as I said, this is all going on inside IETF. There's a working group on it. You can see the URL to their site. The mailing list is weirds@ietf.org. The chairs are Olaf Kolkman and Murray Kachare. And what IETF is asking for at this point is, help standardizing how this protocol is going to work, ideally from sane people, but not necessarily sane people who know something about operations and have a need of the data. And if you look at all of us in this room, we certainly need this data in our anti-abuse work that we do day in and day out. So, what are the benefits for domain names with WHOIS? Well, WHOIS really handles the strong management of the registry, registrar, and registrant model from day one, something that WHOIS struggles with. So it handles referrals gracefully because you can essentially represent a delegated object in the hierarchy with just yet another URI. It also defines a common data model with data labels. So a person actually gets labeled as a person, a role gets labeled as a role. That should help you as you're parsing this data so that way you can reach out to other networks or build geolocation databases or however you use WHOIS data. It supports internationalization for both the domain itself and registrant information. And using things like HTTP authentication, we get things like class of service differentiation to various types of users of the interface. So, WHOIS only has one flavor of service today. It's the anonymous-based interface. Running WHOIS over HTTP or HTTPS would actually support authentication. You could give different data based upon who's asking. So I'm sorry this isn't zoomed in more, but if you can see the output of this, this is a typical domain name registration that is being output in WHOIS format as a JSON object. So this is incredibly machine readable and parsable. That's kind of nice. So that's for a regular domain registration. And then at Dyn, we run a free dynamic DNS service. This is a free dynamic DNS hostname with some WHOIS information, or some WHOIS information by WHOIS being carried out that we are thinking of exposing. So what are our interests, right? So for our customers, we want to make sure that we're able to support their internationalized domains and their internationalized contact information for their registrants. From the anti-abuse perspective, we want to be able to ensure that people who are doing data collection or research have a very easy machine parsable way to get this data. We think it will help speed our abuse desk response times. And then even on the privacy front, remember how I was talking about different classes of service? Well, WHOIS provides a framework so that way if you anonymously come query the service, maybe you don't get the full contact information because maybe you don't need it. Whereas if you are an authenticated user, you can have the full contact information about something. Something we're certainly exploring. And that's probably a whole different talk. So our next steps is to finish the development of a WHOIS implementation. That will be posted up on our GitHub page, so monitor that. And we will eventually offer a experimental implementation at whois.dyndns.com. We will put some data from both our free dynamic DNS host names in there as well as registered domain names. And that's about it. Thank you for listening to this talk about WHOIS and what it can do for registration information. Any questions? Thank you.
Thanks, Tom. Okay, we have a little bit of extra time, so we're going to have an extra lightning talk, and it's going to be Patrick Gilmore in high def talking about World IPv6 launch.
Hi, everybody. I'm Patrick. This is Tigger. Where's the thing? There it is. So, welcome to World IPv6 Launch Day. I'm glad you're all still here and the planet Earth did not implode. There we go. So these stats are very, very fresh. I literally pulled them out at between 8:45 and 9 a.m. this morning. Haven't gotten everything. There was some legal requirements that I couldn't give everything out, some stuff that we were going to do press releases with other people, and strangely our lawyers don't want us to say everything, but I got some data, so let's see what it looked like. So just so that everybody understands, we do have a lot of people on IPv6. It turns out a lot more than we had last year on IPv6 launch, on IPv6 day as opposed to launch day. Some stats that we are allowed to give out, over 700 government sites on 21 different agencies. 1/3 of the top 30 World IPv6 Launch Day participants, if you do them by Alexa rank. That, by the way, is company-based, obviously not individual page-based. So, point is that we do actually have some real data to show here. There's a lot of customers on our site, on our system using v6. And just so that you understand, there's actually more v6 now than there used to be. I mean, it's going up quite rapidly. There's actually some of the sites have 1.5% on v6 native, and that's compared to what it was last year, compared to what it was 2 months ago. That's actually quite a bit. So a little bit of what we've been trying to do. We try to dual stack every single server. Every single Akamai server actually has the ability to dual stack. Strangely, not every network does. We succeeded in getting 53 countries. That was as of Monday. It might have been 1 or 2 more by now. And over 200 network providers. Realize that we have servers in over 1,100 network providers. So people say things like the backbone or the network's easy to do. It's the end user or the website or whatever that's hard to do. Turns out that most of the backbones and networks actually have not v6ified themselves. So all that stuff about the ISPs are ready, it's just the users or the websites that aren't ready, that's incorrect. There's a lot of ISPs that are not ready. And even some of the ISPs that gave us v6, they said, hey, well, you have v6, here you go. And then we tried it out, and it turned out they didn't have all of v6. And so hilarity ensued. Some graphs. Some of these graphs are Martin Levy style. In other words, they don't have any axes. Sorry, that's the way life is. I just pulled out the HTTP only. We have a dedicated SSL where if you have a customer-owned cert, you can put it into your into the Akamai system. I didn't include those. I didn't include streaming. It's very quick. Just let's get it. It's only about 10 to 20% more than HTTP by itself. So this should give you at least an order of magnitude, an idea of what's going on. And just so you understand, the traffic earlier this week, before today, was over 100 times as much v6 traffic as it was last year on v6 day. So we really have gotten, a couple orders of magnitude more traffic. It actually is significant now, or as I like to say, it's measurable. So the red line is midnight UTC. As you can see, we had a massive increase right now. Wait a minute, no we didn't. Oops. Yeah, not a whole lot happened. It turns out everybody was v6ifying themselves before launch day. This is a good thing. And users didn't notice. There was nothing, it was a non-event. This is awesome. So let's back this up a little bit. I think the battery's dying here. Sorry you can't actually see it because it's a little there. The grid actually is days. Probably a better way to look at it is each peak is a day. And you can tell when big customers came on the system. It's not hard to figure out, is it? Anybody want to guess when Facebook came on? Moving on. This is actually, if you go to akamai.com/IPv6, you can actually get this. This is a live open graph. I actually eyeballed the red line here because it's not very well put up, but it's approximately midnight. As you can see, even this only shows hits, not megabits, but it gives you actual hits. As you can see, nothing. There is the data here, the first look for IPv6 is that it was a non-event. We had v6 before, we have v6 now, everybody's happy, it just works. The only interesting thing about the hits is this is the overall hits, and you can actually go to akamai.com/IPv6 and click on these things yourself. This is overall, and then North America. North America is about 75% of the hits. Remember, Akamai is a service provider. We do whatever people tell us to do. So there are some customers, there are some countries and things like that where v6 is pulled back either for performance, breakage, or whatever reasons. Turns out North America, at least from our data set, which I admit is somewhat US-centric, but not 100% US-centric, turns out North America is a little more ready than some of the other countries around the world. Even some countries that say that they're really ready, like, I don't know, maybe Japan or something, that have had v6 for a long time, have a lot of breakage. And, oh, I went backwards. I think that's the last slide. It is. Any questions? Anybody want to get up and ask, well, did traffic increase? Because the answer is no.
I actually have a quick comment, which is that you mentioned all the government sites, and there's a lot of government activity surrounding World IPv6 Day, but the government also has its own mandate for September 30th, 2012, so you might see some things happening around then as well.
Absolutely. When that 5 megabits of traffic comes on. Sorry, it's just things in .gov don't get a lot of traffic. I mean, it's important traffic, you know, people need to go to those sites, but let's face it, compared to, you know, Netflix, Facebook, et cetera, it's just not a lot. Everybody over there.
Randy Bush, IIJ. You're in Canada. Which government?
We're in Canada. I'm sorry, what did it say?
Everybody keeps referring to the government.
Yeah, I noticed when Michael said the government. Yes, we are talking about the federal government. We do, the U.S. federal government, which is why I said .gov. We do have other government sites on Akamai, but I don't know how many other governments have v6 mandates. So .gov is what's important. Most of them, well, I don't know about most, but many of them have already v6ified. Any other questions?
Yeah, I apologize for that. And we were both talking about the U.S. government, and I think if we included the Canadian government, then it would be a full 10 megabits per second. So I think, thanks.
All right. Well, since I'm standing between you and coffee, and I'm sure you all need it after last night, thank you. And just remember, v6